Hi, in this video I will show you how to make a post layout simulation of our inverter. For that we will start from our folder which we already know. There are several different files in it. The most important now is the inverter.pex.spice, which is the new netlist, which include the parasitic components of the layout, which are resistors and capacitors. So for the post layout simulation we need to run Xscheme. Let's maximize this window, and now let's open our test bench, which we already created for the inverter. This is this one, and we can okay, let's select the folder, because we want to change something in ngSpice, so we want to be on the right path. Now we can make a netlist and simulate. So this is the a plot which we have already seen, so it works. Now we want to change this inverter, or simply this two transistor, this netlist of this test bench, to a new netlist, because if you see, if I open the netlist, there are the transistor. There are the transistors which we created in schematic, but we want to exchange this netlist to the new netlist. For that we need to open a symbol of the inverter, and press Q to properties and change this subcircuit to primitive component. Save this, and also in this ngSpice command we need to include the path of our new netlist. For that, a simple way is to go to the to our directory and simply copy. We cannot copy this, but the path for our new netlist is false designs SkyInverter. So we need to put this path here inside. This is false designs Sky Inverter and inverter.pex.spice. This is the new netlist which we include in this test bench. So now we are ready to run a new simulation. Let's save this and netlist and run simulation. So now you see that something goes wrong, because we are on this red line as the input voltage, which is correctly swept between 0 and 1.8 volt, but our output voltage is 0. We have made a mistake somewhere, and we need to fix that. So I will close this, and let's go to the netlist again and see that the pins of this inverter, as they are VDD, VIN, VOUT, and GND. I suppose that these pins are different in our new netlist. So let's go to our netlist again. Now I need to open a new terminal, because the first one is already the Xgame runs with this first terminal. So I have opened the second one, and now let's we need to edit this file. So let's put gedit, and let's see what pins are in the netlist. So now you see that the netlist of our layout has this labels VP, which is VDD, but the second one is VN, but in our simulation test bench is VN. So we need to change these pins so that they match with this test bench. So I need to put on this place A, which is VIN. Second one is VOUT, which is Y, and at the end is GND, which is VN. And the last two I need to delete. Now the 4 pins in our layout netlist matched with the pins of our test bench. VDD is simply VP, VN is simply A, and VOUT is Y, and GND is VN. Now save this file, close this, and go back to the Xgame. This netlist close also. Now we can run netlist and simulate again. And now you see that our simulation has worked, because we see on the output the inverter, the typical behavior of the inverter, so as before. This conclude this series of videos which I want to make to show you the design flow, the analog design flow in open source tools. We have made a schematic of a simple inverter in Xgame open source tool, and we simulated this inverter with ngSpice. Now, in the second step, we have made a layout in Magic, in which we created layer the transistors from scratch on, with different layers on top of each other, and connected them so that they made transistors, and then connected this transistor to a functional device, which is inverter. In next step, we have made another layout in key layout tool, which we choose another way to make a layout, and we simply put the transistors from the library and connect them. This approach was far simple as in the Magic, and much faster. And in the next step, we have made verification steps for the layout for the Magic layout, and you have seen that DRC LVS has been completed successfully, and then we have made a parasitic extraction, which have extracted the components, parasitic components, as resistors and capacitors from the layout, and put it into new netlist, which was called inverter.pex.spice, and we would be able to simulate this new netlist, although there was a issue, because the pins have not been matched between the test bench we have set up and the netlist. So we need to compare and check every time if the pins are equivalent. They need to be equivalent. So this series of video is been done, and I will see you in the next video. Thank you.